Lieutenant Karl Timmermann watches the Ludendorff Bridge disappear behind a column of smoke and debris. The explosion rattles his teeth from 400 yards out. Chunks of timber and stone arc through the gray March sky above the Rhine. For 3 heartbeats, maybe 4, the bridge vanishes entirely behind the blast cloud. His men drop flat. This is the moment every American commander dreading a Rhine crossing has anticipated for months. The Germans destroying their last escape route, sealing the river as an impassable barrier. The smoke clears. The bridge is still there. Timmermann blinks. The 2 stone towers at each end frame a span of steel that should not exist. The roadway sags in places. Debris litters the deck, but the structure stands, stretching across the Rhine like some kind of impossible gift wrapped in cordite and confusion. It is March 7th, 1945. 4 months ago, the Wehrmacht pushed American forces back 50 miles in the Ardennes. Now Timmermann is staring at the only intact bridge over the Rhine in all of Germany. The Germans had rigged it with 600 kilograms of explosives. They had engineers standing by with the detonator. They had explicit orders from the highest levels of command to destroy the bridge the moment American forces approached. And when Captain Willi Bratge gave the order to blow the charges, his men pressed the plunger. The bridge jumped, shook, held. What Timmermann does not know, what he cannot know from the west bank of the Rhine, is the chaos unfolding on the German side. Frantic engineers are checking connections. Officers are screaming. Someone is trying a backup detonator. In a few minutes, a single sergeant will sprint onto the shaking span with a flamethrower to ignite the charges manually, and he will succeed in triggering a secondary explosion that still fails to drop the bridge. They threw everything at it. The bridge took it and held. This is the kind of story that changes wars. A single piece of infrastructure that refused to die, defended by men who did everything right and watched it go wrong. The Germans would spend 10 days trying to destroy the Ludendorff Bridge with artillery, V-2 rockets, Luftwaffe bombers, frogmen, and floating mines. They would execute 4 officers for failing to bring it down. And by the time it finally collapsed on its own, 10 days later from the accumulated damage, 8,000 American soldiers had already crossed it. 8,000. The first bridgehead over the Rhine, the beginning of the end. This isn't the story they tell in the textbooks. If you want to understand how the Third Reich actually collapsed, hit subscribe and drop a comment. A like tells the algorithm this is worth showing to people who care about real history. The Ludendorff was never supposed to be an important bridge. Built during the First World War to move troops and supplies, it was a single-track railway span with a pedestrian walkway on each side. The stone towers looked medieval. The steel truss looked industrial. Together they gave the span an air of permanence that would prove darkly ironic for the engineers tasked with killing it. By early 1945, the bridge had been wired for demolition for months. Standard procedure. Every Rhine crossing had charges in place. The Ludendorffs were substantial. Industrial explosives packed into the support structure, with multiple detonation systems for redundancy. On paper, it was overkill. In practice, something had gone wrong at every stage, and the American forces approaching the West Bank on that gray afternoon in March were about to receive a prize that Eisenhower himself called worth its weight in gold. The question hanging over the Ludendorff was simple. How does a bridge rigged with 600 kilograms of explosives survive the moment it was designed not to? The smell of coal smoke and iron filings hung over Remagen in 1916. Hammers rang against steel rivets. The Reichsbahn needed another crossing, and the Kaiser's engineers were building one whether the Rhine wanted it or not. The Ludendorff Bridge was a product of desperation, dressed as ambition. By the third year of the Great War, German logistics on the Western Front had become a nightmare of bottlenecks and competing priorities. The existing Rhine crossings, Cologne, Koblenz, Mainz, were choked with traffic. Troop trains waited hours to cross. Ammunition shipments backed up for miles. The Military Railroad Administration demanded a solution, and Remagen offered the geography: a relatively narrow stretch of river, high ground on the east bank for defensive positions, and enough clearance below for barge traffic. Construction took 2 years. The design was purely functional. 2 stone towers anchored the span to each bank, giving the crossing a fortress-like appearance that served no defensive purpose whatsoever. The steel truss between them carried a single rail line and 2 pedestrian walkways. Total length, 325 meters. The engineers who built it never imagined it would matter to anyone except the scheduling officers trying to move rolling stock. Look at what happened to the other crossings by March 1945. The bridges at Cologne were gone. The spans at Koblenz destroyed. Mainz blown. Bonn dropped into the river by German engineers. From the Swiss border to the Dutch frontier, every single Rhine crossing had been demolished, either by Allied bombing or by Wehrmacht demolition teams executing standing orders. The Rhine was supposed to be a wall. That was the entire point. German defensive doctrine called it the last natural barrier between the Allied armies and the German heartland. Once the Allies crossed, there was nothing between them and Berlin except open country and a crumbling Wehrmacht. The Ludendorff survived this systematic destruction for one reason: it was still useful. German forces retreating from the Eifel Mountains needed a way across. Trains loaded with equipment, trucks packed with ammunition, horse-drawn wagons, columns of exhausted infantry, all of them funneling toward Remagen because the other options no longer existed. Captain Bratge's orders were explicit: keep the bridge open as long as possible for retreating units, then destroy it the instant American forces came within range. Simple enough on paper. The problem was timing. Blow it too early, and you strand your own forces on the wrong side of the river. Blow it too late, and the enemy takes it intact. Bratge had to thread a needle while American armor was already visible on the ridgeline above Remagen. The demolition charges had been in place since January. 600 kilograms of military-grade explosives positioned at structural weak points identified by engineering surveys. The detonation system used electrical primers connected to a central plunger, standard Wehrmacht procedure, tested and reliable. A backup system existed, a manual ignition point accessible from the bridge deck itself. The Germans had planned for redundancy, for American artillery cutting the wires, for almost everything. What they hadn't planned for was what happened to their explosives between January and March. The Wehrmacht's supply situation in early 1945 was catastrophic. Everything was being cannibalized. Vehicles stripped for parts, ammunition rationed, fuel hoarded for operations that might never happen. And explosives, military-grade explosives, were desperately needed for defensive positions all along the shrinking front. Someone in the logistics chain looked at 600 kilograms of demolition charges sitting unused on a bridge that might not need to be blown for weeks and made a decision. By the time Bratge received his final orders, his 600 kilograms had become something considerably less. The exact amount remaining is disputed. The records are fragmentary. But the engineers who wired the replacement charges knew they were working with industrial mining explosives instead of military-grade material. Slower detonation velocity and less predictable shock propagation. The kind of explosives you use to crack rock, not sever steel. The Ludendorff Bridge had been born from military necessity. 29 years later, military necessity was about to betray it. The order sat in filing cabinets across the Western Front. A single sheet of paper, stamped with the authority of the Führer himself, dated from the autumn of 1944. Any officer who destroyed a bridge prematurely, before explicit authorization from higher command, would face court-martial and execution. No exceptions, no appeals. The retreating Wehrmacht was hemorrhaging territory, and Hitler had decided that his generals were giving it away too easily. The logic made a certain kind of sense if you squinted at it from Berlin. Bridges were strategic assets. A span blown too early could strand entire divisions on the wrong side of a river. Worse, it signaled to the enemy exactly where German forces were weakest. Hitler wanted his commanders to hold every crossing until the last possible moment, extracting maximum defensive value before destruction. What he got instead was paralysis. Captain Bratge at Remagen understood the stakes. 4 German officers had already been shot for premature demolitions elsewhere on the front. Their names circulated through the officer corps like a warning. The message was unmistakable. Blow your bridge 1 hour too early, and you die. Blow it 1 hour too late, and you might survive to face different consequences. Given those options, most commanders waited. The problem was defining the last possible moment. American armored columns moved faster than German communication lines could track. By early March, the Wehrmacht's command structure in the West had fractured into competing fiefdoms of authority. Corps headquarters gave orders that contradicted Army headquarters. Army headquarters couldn't reach Corps headquarters because the telephone lines had been cut by artillery. Division commanders made decisions based on information that was hours old by the time it arrived. Bratge needed explicit permission to destroy the Ludendorff. That permission had to come from Major General Bratge at the division level, who needed approval from his corps commander, who was waiting on authorization from Army Group headquarters. The chain stretched all the way back to Berlin, and Berlin was not paying attention to Remagen on the afternoon of March 7th. The first American tanks appeared on the ridgeline above the town around 2 in the afternoon. Bratge sent an urgent request up the chain. The request disappeared into the administrative fog of a collapsing army. Hours passed. American infantry began moving through Remagen streets. Still no authorization. Bratge was watching his window of opportunity shrink to nothing, and the only response from higher command was silence. This was the second failure point. Degraded explosives were the first. Command paralysis was the second. Neither alone might have saved the bridge, but together they created a gap just wide enough for American initiative to exploit. By 3:30, Bratge made the decision himself. He could no longer wait for authorization that might never come. American soldiers were close enough to the bridge that he could see individual faces through binoculars. He ordered his engineers to blow the charges. The plunger went down. The explosion ripped through the span. The bridge shuddered, sagged, and held. The next minutes fell somewhere between tragedy and farce. Sergeant Faust, an engineer who understood that the electrical detonation had failed to complete the job, grabbed a flamethrower and sprinted onto the bridge deck under American small arms fire. He reached the emergency ignition point and triggered a secondary blast. More debris, more smoke, more shaking. The bridge absorbed it all and stayed standing. The men who pressed that plunger had done everything their training demanded. Procedures designed by competent engineers, followed to the letter. Improvisation when the primary system failed. And still they watched 600 kilograms of explosives, or whatever remained of them, fail to sever a single critical structural member. Hitler's order had cost them the hours they needed. The logistics cannibalization had cost them the explosives they required. Now the Americans were running across the span, rifles up, expecting to die with every step. Hauptmann Friesenhahn ran his fingers along the detonation wire and found the break. American artillery had severed the main electrical circuit sometime in the past hour. The backup line was intact, but the backup line connected to charges that were no longer what the demolition plan specified. The original explosives had been detonator, a military-grade composition designed for precisely this kind of structural demolition. High detonation velocity, predictable blast characteristics. German engineers had used it to drop bridges across Europe with surgical precision. A charge properly placed at a structural weak point would transfer its energy into the steel, creating a shock wave that fractured the metal at the molecular level. The bridge didn't fall apart, it shattered. What Friesenhahn had instead was Westphalian mining explosive. Slower, less powerful, designed to crack coal seams, not sever hardened steel trusses. The substitution had happened weeks earlier, somewhere in the logistics chain, by someone who probably never saw the Ludendorff Bridge and certainly never calculated the energy requirements for dropping it into the Rhine. Mining explosives work through what engineers call heaving action. The blast expands outward, pushing material away from the detonation point. Military demolition charges work through brisance, a shattering force that propagates faster than the material can deform. The difference matters enormously when your target is structural steel designed to flex under load. The Ludendorff's truss members were built to absorb stress. That was the entire point of the design. Railroad bridges carry enormous dynamic loads, locomotives weighing hundreds of tons, rolling stock that shifts weight with every curve and grade change. The steel had to bend without breaking. German engineers in the First World War had solved this problem by using a modified Warren truss configuration. The diagonal members transferred load in alternating tension and compression, distributing stress across the entire span rather than concentrating it at any single point. A beautiful piece of structural engineering for its intended purpose, a nightmare for anyone trying to bring it down with inadequate explosives. The technical term is redundant load paths. Cut one member, and the adjacent members pick up the slack, damage a connection point, and the truss redistributes forces around the failure. To drop a bridge like this, you needed to sever multiple critical members simultaneously, overwhelming the structure's ability to compensate. That required charges positioned with precision and detonated in sequence, each one calculated to remove a specific piece of the structural puzzle. Friesenhahn's charges were positioned correctly. The engineering surveys from January had identified the weak points, but the replacement explosives didn't carry enough brisance to actually sever the steel. They would damage it, deform it, maybe crack it. They would not cut through it cleanly. The blast lifted the bridge off its foundations. One German engineer later reported to American interrogators. "We saw it rise. We were certain it would fall. Then it came back down." That description matches what happens when heaving explosives detonate against a flexible structure. The energy pushes outward, the structure moves, and then, because the members haven't actually been severed, springs back toward equilibrium. The bridge absorbed the blast the same way it absorbed the dynamic loads of passing trains. It flexed instead of breaking. The severed firing circuit compounded everything. Friesenhahn's backup detonator triggered the charges, but the timing was off. Demolition sequences depend on millisecond precision, each charge firing in order, each blast weakening the structure for the next. With damaged wiring, some charges fired late, others may not have fired at all. The coordinated destruction became a ragged series of explosions that the Ludendorff's redundant structure absorbed piecemeal. 3 failures had now stacked against them: inadequate explosives, damaged circuits, a structure engineered to survive exactly the kind of distributed damage it received. The Americans didn't know any of this. They saw the smoke, heard the blast, watched the bridge shake, and then watched it hold. To them, it looked like a miracle. To the German engineers standing on the east bank, it looked like physics refusing to cooperate with desperate men working with compromised materials and broken equipment. The most consequential tactical decision of the Western Front campaign was made by a lieutenant who didn't have permission to make it. Karl Timmermann stood at the western approach to the Ludendorff Bridge with his rifle platoon, watching smoke clear from the failed demolition. His orders covered taking the town of Remagen. They said nothing about crossing the Rhine. No American officer below Army level had authorization to attempt a river crossing. The operational plans called for a deliberate assault further north, with weeks of preparation and concentrated forces. What Timmermann saw in front of him was a standing bridge that shouldn't exist and a chain of command that couldn't respond fast enough to exploit it. He went anyway. The first men onto the span moved at a crouch, rifles up, expecting the deck to disappear beneath their boots with every step. The planking was splintered from the blast. Gaps showed the gray water 60 feet below. Somewhere ahead, German machine guns opened up, the distinctive ripping sound of MG-42s cycling at 1,200 rounds per minute. Bullets sparked off steel trusses and whined into the river. The noise was overwhelming. Engine roar from tanks on the west bank, the crack of rifles, the hammer of automatic weapons echoing off the stone towers, American voices shouting orders that nobody could hear. Sergeant Alex Drabick made it across first. He sprinted the final 100 meters, with tracers snapping past his ears, threw himself into a crater on the east bank, and became the first American soldier to cross the Rhine since Napoleon's era. Behind him came the rest of Timmermann's platoon, then more infantry, then combat engineers who started cutting demolition wires before the Germans could trigger any remaining charges. The crossing took approximately 20 minutes. In that window, roughly 100 American infantrymen got across under continuous fire, seized the tunnel entrance on the east bank where German defenders had taken cover, and established a perimeter that would hold through the night. Casualties were lighter than anyone expected. The German gunners on the heights were firing at maximum range, their aim disrupted by American tank fire from Remagen. What makes this remarkable isn't the courage involved. Infantrymen had been doing courageous things throughout the war. The remarkable thing is that Timmermann made the call without authorization. His battalion commander approved it on the spot, and within hours, the decision had escalated all the way to Eisenhower's headquarters, where it was ratified rather than countermanded. Compare that to Bratge's situation. The German captain needed permission from division, corps, and army group before he could blow his own bridge. The authorization never came. The American lieutenant needed permission from no one. He saw an opportunity, assessed the risk, and moved. This was the difference that mattered, not better weapons or superior numbers. The American command structure trusted junior officers to make consequential decisions in the absence of orders. The German command structure, by March 1945, had been terrorized into waiting for permissions that couldn't arrive in time. Timmermann's gamble paid off because the bridge held long enough for reinforcements to follow. Within 24 hours, the Americans had 8,000 men across the Rhine. Within 48 hours, they had armor and artillery on the east bank. The bridgehead expanded faster than the Germans could organize a counterattack. The Luftwaffe tried. They threw everything available at the Ludendorff: jet fighters, dive bombers, conventional aircraft, even V-2 rockets repurposed for tactical strikes. The Americans brought up anti-aircraft batteries so dense that German pilots reported the sky over Remagen looked like a solid wall of tracer fire. One Luftwaffe officer described the flat corridor as suicide to enter. They entered anyway and died in the dozens. The bridge itself was dying too. The failed demolition had cracked structural members that were never meant to carry this kind of traffic. American engineers shored up the damage with timber and steel plate, working around the clock while the span groaned beneath them. They knew it couldn't last. Artillery shells walked across the river in overlapping patterns, geysers of brown water erupting around the bridge's stone foundations. The Germans had pulled every howitzer within range and pointed it at Remagen. 105mm guns, 155s, even railway artillery from further back. The bombardment started within hours of the American crossing and didn't stop for 10 days. The shells kept missing, not because German gunners lacked skill, but because American counter-battery fire was systematically destroying their positions. Sound-ranging equipment triangulated each German battery the moment it opened fire. Within minutes, American 155s were dropping rounds on the source. The Wehrmacht was fighting an artillery duel it couldn't win. Every salvo they fired revealed their position to an enemy with more guns and more ammunition. The Luftwaffe fared worse. Arado 234 jet bombers, the fastest aircraft in any inventory, made repeated runs at the bridge. They came in low over the hills, engines screaming at 500 miles per hour, dropping 500-kilogram bombs that threw spray 100 feet into the air. The problem was accuracy. Jets couldn't slow down enough for precision bombing, and the bridge was a narrow target. Most bombs landed in the river. The few that hit the span did less damage than the traffic crossing it. American anti-aircraft guns turned the sky above Remagen into a kill zone. 90mm batteries ringed the bridgehead. Quad-mounted 50-caliber machine guns covered every approach. Automatic weapons directors tracked incoming aircraft and computed firing solutions faster than human gunners could react. German pilots reported that the flak barrage started before they could even see the bridge, a solid curtain of tracer and shrapnel that extended from the hilltops to somewhere above 10,000 feet. The Luftwaffe lost more aircraft over Remagen in 10 days than it had lost in some entire months of the war. Pilots who survived described the experience as suicidal. They went anyway, because the orders came directly from Hitler, who had declared the bridge a priority target and was executing officers who failed to destroy it. Then came the V2s. This was unprecedented. The ballistic missiles had been designed for strategic terror, launching from the Netherlands, arcing through space, and falling on London or Antwerp at speeds no defense could intercept. Nobody had ever tried to use them against a tactical target. The guidance systems couldn't hit a specific bridge. They were lucky to hit a specific city. But Hitler ordered it done anyway. 11 V2 rockets were fired at the Remagen bridgehead between March 8th and March 17th. The closest impact landed 300 meters from the bridge. Several fell in open fields. One struck a house in Remagen and killed 3 American soldiers, the only casualties the V2 offensive inflicted. The rockets cost more to build than entire fighter squadrons, and they accomplished nothing. Frogmen swam downstream on the night of March 17th, carrying demolition charges in waterproof bags. American sentries spotted movement in the water and opened fire. Searchlights swept the river. The swimmers who weren't killed outright were captured before they reached the bridge piers. Their explosives were recovered and added to American stockpiles. Everything Germany could throw at the Ludendorff Bridge, artillery, jets, ballistic missiles, frogmen, failed to bring it down. The Wehrmacht was watching its last natural defensive barrier dissolve, and the most concentrated effort in the dying Reich's arsenal couldn't restore it. The bridge finally collapsed on March 17th. American engineers had been watching the stress indicators for days. The structure was failing from the inside, cracked members spreading and connections loosening as the accumulated damage from the botched demolition finally caught up. 28 American engineers died when the span gave way. They had known the risk. They stayed on it anyway, because the repair work had to continue until the pontoon bridges were ready. By then, it didn't matter. The Americans had 3 spans across the Rhine. The Arado 234 was the most advanced bomber in the world, and it accomplished nothing. German pilots had entered the war with the finest tactical training any air force had ever produced. They had swept the skies over Poland, France, the Low Countries. They had fought the RAF to exhaustion over Britain. They had ranged deep into Soviet territory when fuel allowed. Now they were flying aircraft that could outrun any Allied fighter, carrying bombs that could have cracked the Ludendorff's spine, and they couldn't get close enough to aim. The sound reached them before the tracers did. A sustained roar from the valley below, thousands of weapons firing simultaneously, the noise rolling up the Rhine gorge like thunder that wouldn't stop. Pilots who survived described seeing the flak corridor for miles out, a shimmering curtain of steel fragments and explosive bursts that seemed to fill the entire airspace above the river. Black puffs from the 90mm batteries, orange streaks from the quad 50s, white trails of smoke from shells that had already detonated, hanging in the air like markers warning them to turn back. They didn't turn back. The orders came from Berlin. Major Hans-Georg Becher led one of the early jet attacks. His Arado came in at 480 miles per hour, too fast for conventional interceptors, theoretically too fast for anti-aircraft gunners to track. The Americans tracked him anyway. Their SCR-584 radar locked onto his aircraft before he crossed the ridgeline. The M9 director computed his speed, altitude, and heading, then fed firing solutions to the 90mm batteries. By the time Becher could see the bridge, the shells were already in the air. The Arado shuddered. Fragments punched through the wing. Bratge released his bombs somewhere over the river, he couldn't say exactly where, and dove for the deck, trying to get below the flak envelope. Behind him, the bombs raised twin columns of water, 100 meters from the nearest pier. We had never encountered anything like this concentration, one Kampfgeschwader 76 pilot reported afterward. The Americans seemed to have unlimited ammunition. They did. American logistics had stockpiled anti-aircraft rounds at Remagen faster than the batteries could fire them. Trucks rolled in around the clock, unloading crates of 90mm shells, belts of 50 caliber, fuses, primers, replacement barrels. The supply chain that couldn't deliver Donnerite explosives to German engineers delivered everything the American gunners needed and more. The jets kept coming. 11 Arado 234s attacked the bridge over 10 days. 7 were shot down or damaged beyond repair. The 4 that survived accomplished nothing measurable. Their bombs either missed entirely or struck sections of the bridge that the Americans had already reinforced. One pilot released his payload into the town of Remagen itself, killing German civilians who had been too slow to evacuate. The promise of jet propulsion had been speed. Speed was supposed to make the bomber invulnerable, but speed also made precision impossible. An Arado, at 500 miles per hour, covered nearly 800 feet per second. At those velocities, the margin between a direct hit and a complete miss was measured in fractions of a heartbeat. The bomb sight couldn't compensate. The pilot couldn't correct. The aircraft screamed over the target, and the bombs fell wherever physics dictated. Meanwhile, the American gunners had time. Their fire control systems tracked targets automatically. Their radar predicted where the aircraft would be when the shells arrived. Their ammunition supply never faltered. They could afford to miss 1,000 times because the 1,001st shell would still be available. The Luftwaffe was fighting the future with the present. The Germans had built the faster aircraft. The Americans had built the system that made speed irrelevant. By March 15th, Kampfgeschwader 76 had effectively ceased to exist as a combat formation. The survivors were reassigned. Their Arados sat in revetments without fuel or pilots. The bridge they had been ordered to destroy was already carrying American armor into the German heartland. The steel treadway panels weighed 2,900 pounds each. Soldiers called them chess pieces because of how they locked together, tongue and groove connections that snapped into place with a sound like a rifle bolt closing. Each panel was 12 feet long, wide enough for a Sherman tank to roll across without catching its tracks on the edges. The Americans had thousands of them stockpiled at Remagen before the Ludendorff even started groaning. The first pontoon bridge went up 300 yards downstream from the railroad span. Engineers worked through the night of March 10th, floating rubber pontoons into position and anchoring them against the current before dropping treadway panels across the gaps. German artillery fell sporadically, a shell here, a shell there, but the counter-battery fire kept most of the guns silent. By dawn, trucks were rolling across. By noon, armor was following. The second bridge went up 400 yards upstream. Different design. This one used pneumatic floats instead of rubber pontoons. Heavier construction to handle the 60-ton tank destroyers that were starting to arrive at the bridgehead. Engineers from the 291st and 276th Combat Engineer Battalions worked overlapping shifts, one crew sleeping, while another drove piles into the riverbed. Look at the numbers. The original Ludendorff crossing had a capacity of roughly 1 division per day. limited by the single-track rail line and the damaged roadway. The pontoon bridges changed that equation entirely. Each treadway span could handle continuous two-way traffic, tanks in one lane, supply trucks in the other. The bottleneck moved from the river to the roads on the far side. By March 12th, 4 American divisions had crossed into the bridgehead. By March 14th, 6. The perimeter expanded from a few hundred yards to several miles, pushing into the hills east of the Rhine, overrunning German observation posts that had been directing artillery fire. The engineering achievement wasn't the bridges themselves. Pontoon construction was standard doctrine. Every combat engineer battalion trained for it. The achievement was doing it under fire, at night, with German aircraft making attack runs and artillery walking shells across the work sites. One engineer sergeant from Ohio described the experience as building a house while someone throws rocks at you, except the rocks explode. They built the house anyway. The logistics flow that followed tells the real story. Within a week of the initial crossing, American quartermasters had established supply dumps on the East Bank capable of supporting an army, fuel depots, ammunition points, medical clearing stations, field kitchens, everything an advancing force needed to keep moving without looking back. German commanders, watching from the heights, could see it happening. Their reconnaissance reports described convoys stretching back to the horizon on the West Bank roads, vehicles bumper to bumper, an unbroken stream of steel and rubber flowing toward the river. The reports went to Corps headquarters, then Army Group, then Berlin. Nobody could do anything about them. The artillery that might have interdicted the traffic was already destroyed. The aircraft that might have strafed the columns were burning in fields around Remagen. The Wehrmacht had spent 4 years building the Atlantic Wall to prevent exactly this, an Allied lodgment on the continent that could be supplied faster than it could be contained. They had failed at Normandy. They were failing again at Remagen, except this time the reserves were already committed elsewhere, and the Luftwaffe was shattered. The Americans crossed the Rhine with one captured bridge and replaced it with a logistics complex that could support the final drive into Germany. 3 spans became 4. 4 became 5. Each new bridge reduced the value of the original crossing and increased the impossibility of sealing the breach. The German engineers who had fumbled the demolition on March 7th watched it all from prisoner-of-war cages on the West Bank. Their bridge was dying. The American bridges multiplied. 25,000 American soldiers had crossed the Rhine before the first rivet gave way. The engineers on the span felt it before they heard it. A vibration running through the steel deck plates, different from the usual tremor of passing trucks. Deeper. Wrong. The sound came a half-second later. A groan from somewhere in the structure's core, metal twisting against metal in ways the original designers never anticipated. Sergeant William Grubb was working on the upstream truss when the bridge lurched. He grabbed a handrail and watched the deck tilt beneath his boots. Other engineers froze in place, tools still in their hands, looking at each other for some signal about what to do next. The span had been complaining for days. Stress fractures, spreading through members that had absorbed too much punishment. But it had held. It had always held. The center section dropped first. 30 feet of roadway simply fell away, taking men and equipment into the Rhine. The rest followed in a cascade, trusses buckling, connections snapping, the entire structure folding in on itself like a steel accordion collapsing under its own weight. The noise rolled up and down the valley, a sustained roar of destruction that witnesses compared to continuous thunder. 28 American engineers died in the water. Some were crushed by falling debris. Others were trapped beneath twisted girders and drowned before rescue teams could reach them. The Rhine carried bodies downstream for hours. German civilians on the east bank watched them float past. "The bridge just went," one survivor recalled. "No warning that made sense. 1 second you're tightening a bolt, the next second you're in the river, and everything above you is coming down." The men who died had known the risk. Engineering assessments from March 14th had recommended limiting traffic and accelerating the pontoon construction. The Ludendorff was failing. Everyone could see it. The sagging deck, the cracked members, the way the structure swayed in ways it hadn't swayed before. But the repair crews stayed on it, because every hour the bridge remained standing was another hour of traffic flowing east. German observers on the far hills saw the collapse through binoculars. Some cheered. Everything they had thrown at the bridge, artillery, aircraft, frogmen, V2s, had failed. But now it was finally down. The Americans had lost their prize. They had lost nothing. 3 pontoon bridges were already operational. A 4th was under construction. The traffic that had been crossing the Ludendorff simply rerouted to the treadway spans 300 yards downstream. Tanks that would have rolled across the railroad bridge rolled across floating steel instead. The delay measured in minutes, not hours. The collapse killed 28 men and changed nothing about the strategic situation. 6 American divisions were already established on the east bank. Supply dumps stretched for miles behind the bridgehead. The breach in Germany's western defenses was permanent, and no amount of structural failure could restore what had been lost on March 7th. Berlin received the news of the collapse with something between relief and despair. The bridge that had humiliated them was gone, but the enemy it had delivered remained, and that enemy was now driving armor toward the Ruhr industrial heartland without meaningful opposition. The Ludendorff had served its purpose, not the purpose the Reichsbahn intended in 1916, and not the purpose the Wehrmacht intended when they wired it with demolition charges. The bridge had been designed to move German armies westward. It had moved an American army eastward instead, 1 division at a time, for 10 days, until the structure finally surrendered to the accumulated damage of its own botched destruction. The 28 engineers who died on March 17th were the last casualties the Ludendorff would ever claim. Their bodies were recovered over the following days. The wreckage settled into the riverbed and stayed there, twisted steel marking the spot where a railroad bridge had briefly become the most important piece of infrastructure in Europe. The Americans buried their dead and kept crossing. The execution order was typed on standard Wehrmacht stationery, dated March 22, 1945. 5 names, 5 death sentences. The paper smelled like carbon and machine oil, identical to 1,000 other administrative documents processed through German military courts that month. Major Hans Scheller, Hauptmann Willi Bratge, Hauptmann Karl Friesenhahn, Lieutenant Karl Peters, Major Herbert Strobel. The charges varied slightly between defendants, but the verdict was uniform: cowardice, dereliction of duty, failure to execute a lawful order. 4 of the 5 were shot within days. Friesenhahn survived only because American forces overran the area before the sentence could be carried out. The executions accomplished nothing except adding 5 more bodies to the war's final tally. But look at what produced them. Hitler's Autumn Directive had created a system where German officers feared their own high command more than they feared the enemy. Blow a bridge too early and face a firing squad. Wait too long and also face a firing squad. The window between premature and overdue was measured in seconds, and nobody could define it until after the fact. So, officers hesitated. They requested confirmation. They checked their authority. They followed procedures that had been designed to prevent exactly the kind of panicked demolitions that had cost Germany bridges in the East. The system worked. German officers stopped blowing bridges prematurely. They also stopped blowing them effectively. At Remagen, Bratge had the authority to destroy the Ludendorff. He had received that authority in writing, but the standing order required him to preserve the span until the last possible moment, to allow retreating German forces to cross, to deny the enemy any excuse to claim the demolition was unnecessary. So he waited. He watched the Americans approach. He watched his electrical firing system fail, and his backup charges sputter, and his Donnerite substitutes produce a blast that would have embarrassed a quarry foreman. The bureaucracy that executed him for waiting had created the conditions that forced him to wait. American intelligence officers who interrogated surviving German commanders noted the pattern. The Reich's obsession with control had produced paralysis. Officers who might have acted decisively instead requested guidance from headquarters that no longer functioned. Communication lines were cut. Chain of command was shattered. And the institutional memory of courts-martial and firing squads made every commander afraid to exceed his explicit written orders. The Americans faced no such constraints. Timmermann crossed without permission. Engelmann supported him without consultation. Hoga approved it after the fact. The institutional culture that let a first lieutenant make a corps-level decision in 90 seconds had delivered a prize that German bureaucratic precision could not have imagined losing. 28 engineers dead in the Rhine. 5 German officers shot for following a system designed to prevent their failure. And Hauptmann Friesenhahn in an American prison camp, alive because his captors moved faster than his executioners. The morning after the collapse, traffic continued across the pontoon bridges. Shermans rolled east in single file, their treads clanking against the steel treadway panels, exhaust fumes mixing with the smell of river water and diesel. Engineers from the 276th Battalion were already surveying sites for a 6th crossing. Quartermasters updated their manifests. Radio operators logged the coordinates of advancing units. Somewhere behind the lines, Graves registration teams processed the 28 bodies recovered from the river, dog tags and personal effects, letters home that would never be finished. The war kept moving. It always did. A supply sergeant at the Remagen depot finished his morning coffee, cold now, and started counting ammunition crates for the next convoy east.